we're going to go over to our next speaker now, David Kelf, who is actually based in the East Coast of the US. Getting ready for Thanksgiving, I presume, David?
That's right. Hi, Mike. Hi, Disha. Hi, everyone. How are you all doing?
Dave.
Yeah, nice Thanksgiving
Good.
week. And I guess it's not as rainy as we hear it is in England. You got floods and stuff over there?
Yeah, it's been bad. The storm has
Is
reached
it?
us, right? Yeah.
God, I love it.
Anyway,
Yeah.
we do give
Paul as well
we
off.
obviously give, we give thanks for David being available today, and we'll move. I'll give you some background and we'll start. So, Dave Kelf is a CEO of Brecker Verification Systems. The title of his talk is VerifyGPT. Is it possible, and what do we need in place? He's a well-known EDA industry participant, having run Cadence's verification marketing, driven Synopsys verification strategy, and non-marking for code design, just a Verilog, Novas, Verdi, and others. He is now CEO at Brecker, focused on SoC verification and system VIPs, including RISC-V verification. He has a solid engineering background, has performed many ASIC designs, and holds a microelectronics MSc from Brunel University, which is in London, by the way, as well as an MBA. Over to you. Thanks.
Yeah, thanks, Mike. So what I'd like to do is talk a little bit about what we see in the future here and where we see AI being used, particularly in the verification space, of course. Today, as we've just heard from the last two presentations, very good, by the way. We can see AI being inserted all over the place now, in different EDA tools. Brecker had used AI techniques, reasoning algorithms for quite a while, and I can start off by sort of talking a little bit about this, right? So Brecker's in the business of synthesizing test content for dynamic verification, simulation, emulation, and so on. And we've used systems and languages such as portable stimulus and C++ and what have you to do this. And to get a sense of how we leverage AI in this process, if we look at how most test systems are done today for simulation, for UVM in particular, if you imagine a design that has a state space like this diagram where the states are on the vertical axis and the time frame is on the horizontal axis. Well, if we're using sort of standard constrained random techniques, what generally happens is the design is treated like a black box, and tests are randomly shot at it based on a bunch of constraints. So it's maybe a little bit more effective than the diagram here. But you can see that it's limited in terms of heavy sequential depth in terms of the states in a model or in a design. So what we do in Brecker is we synthesize tests based on a model. And what we do is we explode the state space of this model, which represents a scenario or a specification that you want to generate some tests for. And then we use this technique called AI planning algorithms to start essentially with the end in mind. So we start at the right-hand side with the checks that we want to look for. And we go backwards through the state space of the model to the inputs to then generate tests that we can apply to the actual design. So, this is interesting. It sounds a little bit like standard tree walking and that kind of thing. But in fact, what we do is we use this planning algorithm mechanism, which provides a reasoned decision basis to backtrack through the state space to generate much, much more efficient and effective tests. And this is something that we've done for a while. I should point out that IBM is one of the big forerunners of planning algorithms. They use it in the Watson team, and they were the guys that actually introduced us to it first many years ago. And we've written various papers, and you can sort of get various bits of information on planning algorithms, which is actually quite an interesting read from some of these sources here and many others if you do a Google search. So, this is the kind of thing that us EDA companies are doing today, right? We're using AI to effectively figure out how can we make our tools more efficient and work better. And that's nice. However, what we really want to do is this, right? What we want to do is something like a ChatGPT window where you would type in some, as Paul put it, natural language and get out a test bench. And so just for fun, I did this. right before this meeting, and just to see what would happen with ChatGPT. And honestly, it does a pretty good job considering the lack of LLMs and what have you. So it will generate a very simple test bench for, in this case, a DMA controller. You can play with it and get some okay results out of it. But of course, this is nowhere near industrial strength. And so the question is, and the subject really of this presentation is, how do we get there? So what's the problem? Firstly, the problem is that the specification that you have for a design needs to be used to generate tests. And there's lots of issues with that, of course. And in fact, if we look at some standard sort of research data that's generally available from Wilson, you can see a lot of the bugs in designs today are caused because of specification issues, specification problems. So what we need to do is try and figure out how we can take a specification or a set of scenarios that we want to test and convert them directly into actual test vectors, and do this in such a way that the spec is easy to understand, and it's consistent and cohesive. So taking a natural language, actually, as Mike will remember, many years ago, the word in verification was the executable specification, right? Where you would actually type in the spec, and you would be able to have that turned into test vectors, and that would be it. Trouble with that is the spec itself often is incorrect. So what we need is a better way of generating the spec in such a way that it can be absorbed by an AI type tool. So validation, as we know, is basically a search problem, right? It's a state search problem. So what we need to do is try and figure out, a complete state space for what we need to test, break it into manageable chunks, because in general, these state spaces are absolutely vast, and see if we can compose tests by taking pieces of search spaces and figuring out how we can cover those different pieces. So if we were to pretend that we could get a generative approach for this today, the question is, how would this be possible with a large language model? Okay, there are some issues, right? For example, if you're working on a design today and it's a new design and something revolutionary, the question is, can AI, machine learning, basically figure out something that's not been done before, based on an LLM, which is, of course, made up of tests that have been done before? Also, the idea, if you do have a lacking LLM, and they almost certainly would be, how will we deal with hallucinations, which is an AI term, as you probably know, for a kind of a false positive based on a lack of LLM data. Also, if we're learning from essentially a UVM constrained random generator or something of that nature, will AI really be able to improve that? Can we infer new cases based on this random generation? So there's a lot of issues with a straightforward generative approach. How do we get an LLM for this? Well, actually, Paula had an interesting mechanism that you were discussing, which sounds like you're taking customer data and cadence data in that case, and building up an LLM for general verification. And I think for assertions for formal verification, you can see that starting to work. For generating a broad range of dynamic tests, I still think this is a long way away. What we probably would need to do is persuade companies who have generated tests to essentially pool a lot of their test vectors in some large database which we could all access. And that is something which is going to be hard to get some of these companies to do, needless to say. Having said that, we actually see companies like Tenstorrent providing tests for RISC-V International today. So it's starting to happen to a certain extent. But to build a comprehensive LLM from these tests, it's going to be very difficult to persuade enough people to give up their tests and pool them. Maybe Cadence and Synopsys can handle it because of the number of customers, but even there, it's very difficult. So we need to sort of see how we can build up these large LLMs. And what we would suggest is that if we can start from small pieces, like the DMA controller, where there's a good set of tests for that, and then build this into a sort of bigger model, this might be a better way to proceed. The other thing that we should think about is the idea of symbolic reasoning or symbolic AI, which is actually a pretty old AI technique that has been used to augment large language models to actually provide sort of the additional piece that we need to generate new stuff. And this is now seeing a resurgence, as probably many of you know, where people are actually trying to figure out, can we do symbolic reasoning, essentially, which is actually what planning algorithms is based on, and build a knowledge graph and combine that with a straightforward neural network to sort of build up the additional reasoning part on top of what's been learned. This, I think, is probably going to be ultimately the way that we are able to use AI in a real way inside verification, using symbolic AI type techniques to actually build these graphs. And there's some interesting papers on this as well. CL Dim from Harvey Mudd has done actually an excellent job exploring how this actually might actually be able to happen. Today, the question then is, how can we describe an executable specification such that we can build it into a large language model? So if you look at this simple SOC, you can see that we could draw on a whiteboard, a very simple set of tests, right? Something like this, where it's almost like a state machine, and we just pass through a state machine and basically walk it in a hierarchical fashion and generate a bunch of tests. And so this seems, if you're trying to describe one of your test vectors, this seems like a good way of approaching it. So we could take this and we can generate a graph today and make this graph hierarchical. This is basically a portable stimulus graph in the Brecker technology. And this kind of shows how you might be able to describe a pretty straightforward spec. And if you make these boxes hierarchical underneath, you can start to build up a picture of the specification or the system that you actually want to pass into an AI type tool. In reality, it would actually look like something like this. This is a Brecker graph which tests a hypervisor memory management unit. And you can see that this is actually looks pretty complicated, but it's actually built from individual components. And when you start to break this down, it's actually fairly easy to sort of build this up. So the question is, how can we take this and then build up a set of tests from these components into a much bigger test suite through the use of the generative approach of AI and using symbolic AI and logic reasoning on top of it to actually create some of the new pieces. And so this is our belief of where this is going. It's something that Breck is obviously investing in, and you can be sure that there's a bunch of other companies out there investing in it as well. So I think if we're to take a sort of a leap forward, we're going to see AI being used to generate dynamic test vectors for large systems and probably do a pretty good job of it. After all, if we were to sort of look into the future, in the past, we wonder how the Egyptians managed to build these huge pyramids without some, mechanical tools. I think in the future, we're going to sort of see the same thing for AI and semiconductors. And I think the way there is through this process of test suite synthesis, which starts to make use of AI programs, but also provides a framework for how we can define the specification, how we can define constraints, and so on, that actually could be used by an AI tool. So we'll look to the future for when Brecker and other companies can announce something like a VerifyGPT, but we haven't done it yet. So this is not a real press release, but it is something that I think we're going to see in the future. And it's exciting times, right, in EDA. And actually, I really appreciate the last two presentations. I think both the guys there did a great job of showing how we're starting to see AI introduced. And what I wanted to do is sort of provide a higher level view that I think a lot of companies are actually looking at right now. Thank you very much, Mike. Over to you.
Thank you, David.
Yeah, and that's left us some good times for questions as well. Good amount of time for questions. So we'll go through some of the questions, okay, Dave, if that's okay. And yeah, the online there. Question 1 is for David. What did you get cross coverage and functional coverage, please? What results did you get regarding cross coverage and functional coverage?
Are you talking about the planning algorithms slides at the beginning, presumably?
And I think
right?
and what sort of scores can you get through this approach? Do you actually see some improvements in cross coverage and functional coverage?
So it's a great question, and in fact, the way we look at coverage is first we look at the coverage of the actual specification model that we're testing, right? And the way the tools work today, and I think will work in when it comes to these AI systems, is you'll actually define the coverage you want, set it up based on the specification, and then generate a bunch of tests that would be based on that coverage model that you provide, right? So this is the idea of scenario coverage. The kind of coverage we actually get if we then take those tests and run it against the design with an independent coverage model that some of the engineers working on the design have created, and we do this quite a lot. In general, it's pretty good. I do, off the top of my head, have a case study which is public, so it was with Broadcom, on a design that they were working on, and we were looking at power domains and verification of power domains on a complicated cell phone chip. And basically, we were seeing something like 94%, 95% on this pretty comprehensive coverage model they had built, whereas manually, the tests they produced were able to achieve something like 87 and 88% after about 6 weeks work of producing these tests. So that's pretty indicative, I think, Mike. It's something like the sort of mid to high 90s in general. Not 100%. Sometimes you can get 100, but that's unusual with any of these systems, I think. So you always have to go in and figure out the last bit. But it's pretty high.
Yes, closing that verification coverage closure to 100% is still a big challenge. And just on that topic, we do have a webinar tomorrow where we actually going to be looking at a test bench that tries to achieve that. David.
Oh, excellent.
And I noticed you were talking about database, shared databases. That's actually something that we've been trying to do in the UK. We've got a few companies together. It is very, very difficult to all agree to share that data. But I think it's just, I noticed you mentioned Thames Torrent, who I know quite well. So I'll contact them on that. But yeah, maybe collaboratively we can produce that set of data. I think.
Yeah, actually. Well,
the engineers are keen, but the lawyers aren't, as far as I'm concerned.
Yeah, well, that's the problem.
Go ahead.
Exactly. So I think the engineering, organization, these companies see the value, right? So they say, boy, if we can contribute and build something here, we could do something tremendous. But the Thames Torrent case is very interesting, right? So what's happening is RISC-V International are building a certification program for their processors. And they're, people are looking at donating tests and doing things like this. And Thames Torrent have come along and said, well, look, we can give you a lot of our basic tests and we can open source them and provide them. And it's not really, any skin up our nose. And even their lawyers agree with that. But what was interesting, Mike, was that they were doing it to achieve a purpose, right? They were saying, we want to help this certification program because it's really important. So it wasn't sort of some general, hey, we're going to build an AI database. It was something very specific. And I think that might be the way to achieve some of these things, right? If we go to these companies and say, look, we're going to build, a certification program or something like that, then it could be possible to get someone to part with money. So I can give you the contacts of the folks over there who did this. And I think other companies in RISC-V are looking at doing the same thing as well.
Okay, that sounds very good. And we will, I'll be in touch on that. And anyone else who's interested, first of all, building these big databases, do get in touch. We are trying to set up collaborations for the same, and we do have a webinar tomorrow. I think we shall have the details of that for you. And that actually brings us quite nicely to this second question, and maybe we'll close on this second question. Is specific question: how do we get enough domain-specific training data to get this off the ground? It seems that the suggestion Brecker is going to have lots of data, but if they're an individual company, how do they get this off the ground? How do they get enough data?
And that's what we're talking about, right? I mean, this is the big problem. If we imagined, if we waved the magic wand and every single electronics semiconductor company who has a ton of test benches for a whole wide range of purposes donated them all to some huge database, we actually might be able to really succeed with this. But I think you're right that a lot of the bigger companies, the Intels, the Apples, the Nvidias of this world are not going to do that, right? Their lawyers are going to stop them. So I applaud your effort, Mike, to try and get something going in England. And I think ultimately this might be how this happens. And it may be companies like Cadence and Synopsys with their broad reach might also be able to achieve something like this. But it's something that's going to be difficult. And I think reasoning is going to be the way we build on top of these, what we do have for LLMs.
Okay, thanks, David. And by the way, it's a UK effort, not an England effort. I can't be too parochial on
that. I'm sorry, you're right, of course. Yeah, Scotland, Ireland, and
anyway,
Wales are involved too, are they? Good.
Lisa, do you want to share the closing slide, please, and we'll close?
Yes, just give me 1 minute.
And for those interested in collaboration, do get in touch. We are collaborating on this. And we're doing it for free. You don't have to pay to be involved in that collaboration. But the more companies we get involved in, the bigger data sets we get, the better. Okay, Dave? Okay. So, just to close up, thank you for participating today. Thank you to our sponsors, Agnesis, Cadence, Becker, Becker and Synopsys. Tesol, my employer. We do partner with TechWorks, so we thank TechWorks as well. Next slide, please.
Yes. Okay. Just give me 1 minute, Mike. Yeah.
Okay. So the presentations will become available for you on our webpage. You can see it there, and you'll get an email once they're available. You'll get all the PDFs, and eventually you'll get the videos as well. So you'll be able to listen back or share it with your colleagues. Next slide. Yeah, this is as you can see, this is a huge topic. Send me your ideas. We've had a series of free webinars. We can extend that. We have DV clubs all the time. We have our verification futures in UK, Reading, and in Austin now. And this year in the UK, it's going to be expanded. We have a day before where you can come and listen to the tool vendors, and they can talk about this in a lot more detail if you want. But they've got a whole day there as well. Okay. And DV Club Europe next year, there are tentative dates, but we always put in extra ones. And there's our tentative date for the 1st of July at Reading University. That is going to be the big one. And we will be having a sort of EDA tools training day on the 30th of June, the day before. That's a Monday on the 30th and Tuesday on the 1st. And you can join online. We're looking for speakers as well. So feel free to suggest papers on that. Thank you very much. 2 minutes over, but that's only me waffling on at the end. Thank you very much to all our speakers for finishing on time and giving some time for Q&A. And hopefully we'll see some of you tomorrow at the webinar. Thank you.
Yes. Thank you. Thank you, everyone. Thank you for joining the session.